Hey, what's up, y'all? It is Thursday, May 2nd, and if you don't know, today is my birthday. Yeah, it's my birthday. Yeah, okay, let's move on. Cool. So let's just go here. Journal check number 12. This is that. This is that. This is that. That is this. I don't know what I'm talking about. But here we go. So we'll have journal check number. We should go through probably 26. I probably should fix that instead of saying 26C because it's not really 26C to just 26. That's what it should be. I got to move that to go back to the slideshow, do that. Blot out. We back in here. Okay, and this one's going to probably be worth 40 or 45 points, probably 45 because of all of the different things that we're putting in here. So make sure that each day you're getting your stuff, and if you haven't, go back to the agenda slides, go back to the video lessons such as this and get everything in there. Okay. Cool. So let's keep it moving. So in class, all the grades, I just want to let you know, all the grades have been updated, so you should go check. I'm not going to take the time to do that here in this video. You can pause, go check your grades, make sure everything is good. Leave a comment if anything is not, or turn in anything that you need to, but all the grades have been updated, okay? Except for periods 6 and 7, I think hidden figures still needs to be graded. Everything else has been updated, okay? All right, y'all. Let's move on then. Woo. Oh, that beat kind of go. That beat kind of go. Okay, so let's just talk about this. I think I can move myself off the screen. Yeah, so that you guys can see this. So I'm gonna go like this, and then it's on the other screen, so I gotta go find it. Boom, bop, got it. Sauce. Now, you don't have to write down anything just yet. I just want to talk about these things real quick because these can be things that can be confusing, and I do not want them to be confusing, okay? I want to bring as much clarity as possible. No clue where my camera is, but I will. You just have to do it with the voice, okay? So a student uses a computer simulation to determine the variables that affect gravitational forces between two objects. Now, hopefully you remember, right, that what are the two variables? Hopefully you remember in class, a lot of people remember that, oh yeah, they were like, it's mass, and then the other one, they had a little bit harder of a time, but it's mass and distance. So remember, the more mass something has, the more gravitational force it has, and then the closer two objects are together, the greater the gravitational force, and then the further they get apart, then the greater the distance, then the gravitational force starts to go down. That's why the sun has the greatest gravitational force in our solar system, but we're far enough away from the sun that it doesn't pull us all the way in because of the distance. Okay, so with knowing those things, because we taught on those things, so with knowing those things already, we're like, okay, let's just go right here. So for trial 1 and trial 2, you see that the kilograms or the mass are equal to each other. So that part's the same. If you look here, the distances are different. So 4 and 8. So this one is trial 1 is closer, and then trial 2 is further apart. So we would think, since trial 1 is closer, its gravitational force should be stronger. At least that's what we're thinking is going to happen. So let's just take a look. Now, this is one of the things that can be an issue, is the way that the scientific notation is notated. If you look, this is a -9 and this is a -10. So they are different. So also remember when we have, so I'm going to write this out, 2.6 times 10 to the -9. When it's negative, that means it's a small number, and that means we got to move the decimal place. Everyone was like, where? To the right or to the left? To the left, right? Okay, so then we're going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to put it right there. That's going to be 1, 2, 3, 4, 5, 6, 7, 8 zeros, right? 0.0, and there's 8 zeros. Now, you're like, which one's smaller? Which one's smaller? So, because a lot of students guessed that 6.5 was bigger, but you have to remember it's times 10 to the -10. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're all the way over here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So that actually makes this number smaller. So just remember, the more negative it is, then that means right? The more negative it is, the smaller the number is going to be, because that means more zeros here, more zeros. So hopefully you got that. So this is the other question that I asked. Okay, so out of this column here, right, out of this column here, this one right here, what is the biggest number? And hopefully you're like, well, -8 is the smallest one, which means I have to move the decimal place the least amount of times. So this actually is the largest number. That would be correct. Then you would go to -9, because I'm only moving it 9 times to the left. That one is the second largest number. Then you would have to look at these two numbers. They both are to the -10. So then the 6.5 would be the next largest number, and this one would be the smallest number. So hopefully you're able to see that, right? Because that is one of those things that actually is massively important to understand and to see that if you look in this data table, they did not format all of the scientific notation the same. So because of that, right, then you're really going to have to take a look and remember, the lowest negative number is actually the biggest number. Okay, so I just wanted to make sure to put that out there to you guys. So I'm going to close that, go here. Where are we at? Oh, we moved back a little bit, a few places. So let's go to answering the questions in which they had. And this is what I really want you to write down. Okay, bam, let me get this. Do this, put the new. I need to get this so I can write it down as well. Okay, this is where I want you to actually legit write this part down, because I want to get this in your brain again, because it was a while ago that we talked about gravity. Is choose the claim that best agrees with the data. So mass does not affect the gravitational force between two objects. We're like, no, that's not true. Mass is the only variable that affects the gravitational force between two objects. That's obviously not true. The distance, right? The distance is the only variable that affects the gravitational force between the two objects. No, that's not true. It's both mass and distance are the variables that affect gravitational force of two objects. So write that part down. So I want to make sure you got that. Now, we're going to check the data right now to make sure that that's what it says. We know that that's the answer, but we're like, let's make sure the data correlates that. So I'm going to shrink this down, pause this if you need that. So I'm going to go like this, and we're just going to go back one slide and say, okay, when, right? So when the mass is equal, so trial 1 and trial 2, the mass is equal, but the distance is shorter, right? Then we see, oh, -9. That means that the gravitational force is increased compared to when the distance is longer. All right, cool. So now we come down here and say, oh, well, the mass, we have more mass in trial 3 than we do in trial 4, because we got 1 kilogram and 1, and we got 100 kilograms and 100 kilograms. So that's 200 kilograms. So this one's the more. And then if you look here, the distance is the same, but the mass is different now. And the one with the more mass, right? The one with the more mass actually has a lower gravitational force, right? Or has a higher gravitational force to the -8. So this one actually has a stronger gravitational force because the mass is increased. So that means that, our data actually does correlate and say this. All right. Next thing that we're going to look at is these two statements here at the bottom and see if we can decipher them out. So as the mass of the object, right? So as the mass of the objects both increase, so if they both increase, the gravitational force between them also, what we saw was it increased. So as mass increased, so did the gravity. And as the distance between the objects increased, so the distance increased, right? The distance went up, and the gravitational force between them decreased. There's this crazy fly flying around. I'm like, bro, get away from me. I'm trying to teach, my boy. Okay, so hopefully you see those things. Hopefully that's really clear to you guys. All right, I'm going to close that down, shut that down. And then I'm going to pause because I need to look at yesterday's video, because I need to see how far we got with this part. All right, cool cow. This is where we actually left off. So yesterday I had to go double check. So I wanted to make sure I taught everything. So I'm going to go ahead and start writing down these chemical formulas right here. And I'm just going to start from the top to the bottom, okay? So the very first one, right, is, hold on, can I scroll up a little bit? Yep, is HCl. Okay, so that's that one. And then H2CO3. Okay, that's that one. And then I got HNO2. 2. Then I got HNO3. Then I got H2SO3. Then I got H2SO4. Then I got CH3COOH. Okay, that sounds kind of crazy. Okay, so let's just go up to this very first one. Now, some people are like, oh my gosh, that kind of looks HCI, which is cool. But if you look at the name hydrochloric acid, that lets you know that's hydrogen, like right there, right? Like this part looks like hydrogen, and this part looks like chlorine, right? So that's HCl. Now, so if I look at this, there's no subscript, which means it's going to be 1. So for hydrogen, right? So for the H, it's equal to 1. Hydrogen, right? Because I want you to write it out so that way you can get used to what it is. Hydrogen, there's 1. And then for chlorine, hopefully I spelled this correct because I'm always, oh, I already messed up. L. All right, we got to erase. We messed this up. We messed this up. All right, we're going back in for a second try. ClOr, chlorine. There is 1, and the total atoms, right, is 2. So 2 total atoms. Then we got hydrogen, and just so I can save time, I'm not going to write it out, but I want you guys to write it. We have carbon, and we have oxygen, right? HCO. Hydrogens, there's 2 right there. And then carbon, there's 1 because there's no subscript, and then there's a subscript 3 right there. And the total number is 2 plus 1, which is 3. 3 plus 3 is 6. Okay, then we're going to go hydrogen, and then this is nitrogen, and then oxygen. So the hydrogen for this one is 1 because there's no subscript. Nitrogen is equal to 1, and then O2, which is equal to 2, and then the total here is going to be 4. So 1 plus 1 plus 2. Okay, let's go to this one. HN, by the time we finish, y'all should be experts. O. So hydrogen, which is 1, nitrogen, which is 1, and then oxygen, which is 3, and then this is 5. Cool. Let's go ahead and scroll down a little bit, and then we're going to go in. So this is one that you probably need to look at. What is this? This is an S. So hopefully you look that up on your periodic table, and you're like, okay, hydrogen, sulfur, oh, that's one we haven't seen yet, and then oxygen, right? So then for hydrogen, it looks like there's 2. And then for sulfur, it looks like there's 1 because there's no subscript. And then for oxygen, it looks like there's 3. And then that is going to end up being 6. And then for hydrogen here, they are H. This is 2. Sulfur again, it looks like there is just 1. And then for the oxygen, looks like there is 4. So 2 plus 1 is 3, plus 4 is 7. All right, now this is the only one that might have gotten tricky, right? So I see a C at the beginning. That's the carbon, and then there's an H right there. So there must be some hydrogens, and then there's O's and there's oxygen. Are those the only elements I see? Let me double check down here. Let me double check. Yeah, that looks like about right. Okay, cool. So then we're gonna go like this and say 1 carbon, but there's also another carbon over here. So that is 2. There's 3 hydrogen here. There's also another hydrogen here. So that gives us 4. So it's 3 plus the 1 because there's no subscript there. So 3 plus 1, that's 4. And then for the oxygen, there's 2 back to back. And that one is 2. So the total number here is 8. And that's how you count them, okay? So hopefully you're like, yes, okay, I got it. I understand, like, how to actually count that whole thing out, okay? That is how you go about doing it. I'm going to go ahead and save this, which is counting atoms. Boom. Okay, so now I'm going to get rid of that. Boom. And then we're going to move on to one last thing. And what I want you to do is write out this entire data table. So this data table right here, draw just this data table. You don't have to draw anything else. Just draw this data table, and then you are done for today. So again, just draw this data table down here. This is where we're going to start at tomorrow. All right, y'all. Peace.